Welcome back to Devine Inspire Care. Thank you for being here. Ever wondered how we breathe? How the air we inhale transforms into life-sustaining oxygen? Well, let's unravel the mystery together. Our bodies are equipped with an incredible piece of biological machinery known as the respiratory system. A marvel of nature's engineering, its primary function is as simple as it is crucial: gas exchange. Every moment, while we're talking, running, or even sleeping, this system works tirelessly, ensuring we inhale oxygen and expel carbon dioxide. This exchange is at the core of our very existence, providing the oxygen that fuels our cells and removing carbon dioxide, a byproduct of our body's metabolic processes. From the first breath of a newborn to the last sigh of a peaceful slumber, the respiratory system works with clockwork precision, maintaining the delicate balance that keeps us alive. Intrigued? So, ready to dive into the intricacies of this fascinating system? Two main actions make up our breathing: inhalation and exhalation. Let's consider inhalation first. It's an active process that involves the contraction of our diaphragm, a powerful muscle sitting below the lungs. As the diaphragm contracts, it moves downward, creating more space in our chest cavity. Simultaneously, our chest muscles work to expand the chest further, and together they create something akin to a vacuum effect. This decrease in pressure draws air into our lungs, filling them with oxygen-rich air. Now let's shift to exhalation, which is more of a passive process. Here the diaphragm and chest muscles relax, reducing the space in the chest cavity. This relaxation allows the lungs to return to their original size, and in doing so, they push the air out, expelling carbon dioxide, a byproduct of our body's metabolic processes. And that, in essence, is how we breathe. Breathing starts in the nasal cavity, air's first point of contact in our respiratory system. This cavity is lined with mucus-producing cells that play a vital role in filtering and conditioning the air we breathe. The mucus produced is salty and sticky, armed with enzymes called lysozymes that neutralize harmful bacteria. Plus, there's an army of nose hairs standing guard, trapping larger invaders like dust and pollen. So, our noses do more than just smell. They are the first line of defense for our lungs. Did you know our sinuses do more than just create spaces in our skull? They're actually a key player in preparing the air we breathe. Connected to the nasal cavity are 4 sinuses: frontal, ethmoid, sphenoid, and maxillary. These air-filled pockets are like a cozy fireplace for incoming air, warming and moistening it before it heads deeper into our respiratory system. And that's not all. They also amplify our voice. Ever noticed how your voice changes when you have a cold? That's because your sinuses are clogged. After the air has been conditioned by our sinuses, it embarks on a journey through the pharynx, a tube divided into 3 parts: the nasopharynx, oropharynx, and laryngopharynx. Then it reaches the larynx, which houses the epiglottis, a security guard of sorts, preventing food from gate-crashing the party in our windpipe. The path to the lungs is more complex than you might have thought, right? Beyond the larynx is the trachea, or windpipe, a natural highway leading into the lungs. This splits into 2 main thoroughfares, called the main stem bronchi, at a junction known as the carina. Due to its anatomy, the right bronchus is more prone to foreign object inhalation, acting somewhat like the fast lane of this respiratory roadway. As we delve deeper into the lungs, these bronchi continue to divide, forming smaller branches and bronchioles, much like a tree spreading its limbs. But here's where it gets interesting. The trachea and bronchi are surrounded by smooth muscles that are influenced by the autonomic nervous system. During moments of stress, such as sprinting to catch a bus or running from an angry turkey, sympathetic nerves relax these muscles, widening the airways for more oxygen. On the flip side, during quiet moments of rest, parasympathetic nerves can constrict these airways. So, even your nervous system plays a role in how you breathe. The airways are lined with a special cleaning crew, mucus and cilia. These ciliated columnar cells and goblet cells produce a sticky substance known as mucus. Acting like a trap, the mucus catches particles that could be harmful to our lungs. The cilia, tiny hair-like structures, then perform a synchronized dance, moving the mucus and its trapped particles towards the pharynx to be expelled or swallowed. This process, known as the mucociliary escalator, helps to keep our airways clean. Now, let's follow the air as it embarks on its final journey, traveling through smaller bronchioles until it reaches the respiratory bronchioles. Here you'll find small sacs called alveoli, the main stage for gas exchange. Each alveolar wall is thin and lined with type 1 and 2 pneumocytes, with type 2 cells producing a surfactant that reduces surface tension, keeping the alveoli open. And that's where the magic happens. Oxygen diffuses into the blood and carbon dioxide diffuses out. In essence, breathing is a complex yet beautifully orchestrated process. From the initial gasp of air in the nasal cavity to the intricate dance of inhalation and exhalation, every element serves an essential purpose. The mucus and cilia, bronchi and alveoli all work in harmony to facilitate gas exchange. The autonomic nervous system subtly manages this process. And that, my friends, is a brief tour of remarkable respiratory system, a marvel of nature that works tirelessly every second of our lives to keep us alive and breathing.